All right.
Good morning, Professor.
Good morning, Harry. Who else is here? Okay, Maxim is here. Chanyi is here. Well, we'll wait for everybody to turn up. We're just here. Um, hey, Maxim, you got to ask that question in the forum, okay? You can't email me. You can't email me questions about the quest. Everybody okay with that? Yeah, like there's only 3 of you now, but you got to be okay with that. You can't email me or anyone about your quest like that. And people do that all the time, but they also have to be reminded, okay? Because if I tell you the answer, it is useless. You'll just do it and get your points and move on, but you'll never ever be able to use that thing again.
You can put in the ready so we can have a discuss.
Yeah. I'm sorry, what was that again? Let me increase the volume. Yeah, go ahead.
So he can like put in the Reddit.
Yeah, you can, but you can post your code in the Reddit. You can ask. You can say in your Reddit, in the Reddit discussion, this is what is going on. What this is what I want to happen. This is what is going on. What could I be doing wrong? Something like that, right? And lots of people, you'll find that lots of people have asked the same question, but better that you ask the question rather than browse Reddit and find the answer that someone else gave to the same problem someone else had before. Right? Even then, you won't remember it, right? So that's what I mean. In fact, in Indian mythology, there's actually a great story. There's this warrior who wants to learn a particular trick. It's a very, very powerful, not a trick. It's a very, very powerful technique that only a group of people who are peace loving, right? Who basically given up everything for peace, right? So they're not so they know this, but they know this incredible weapon, this incredible technique, but so they'll only teach it amongst themselves to the other people who also are, committed to peace. But this warrior wants to know that, right? Because then he can use it, right, for against the other people. So he goes to learn from that person this trick. And that would have been a decisive win for one of the sides in the battle, in the Great War, in the Mahabharata. So if he had got that technique, if he had learned it successfully, he would have. But as it happens, due to a play of events, and what happens is that his master, his guru, will actually believe that he is a peace-loving person and teach it to him. Right, but then one day, because of fate, the truth is revealed, and his guru realizes that he had just divulged the secret that could destroy the whole world, essentially. Well, it's basically, end the war by giving it to the bad side, right, or the other side. Done that. So then he contrives. The situation is contrived in such a way that this person will now forget the technique he's learned at the right time that he needs to use it, right? And as it turns out that if you need to use it, it's only powerful if used for peace, right? If it's used against peace, that technique is not powerful. So that is how the situation is essentially resolves in the end, without that, what is that divine thing, right? Usually people bring that in to end stories, right? Saying, oh, so what is that? There's a name for that in stories, right? When you you can't resolve an end, you just resort to something out of the world happening to resolve it, right? But here, the situation is resolved nicely because that technique is actually a technique that will only work if used for peace. Right. So even though with peace it can conquer the whole world, it cannot conquer the whole world if used against peace. And that is the essential. So that kind of makes it all conceivable and relatable to humans, right? Other than without saying that it's a supernatural power, right? And things like that, because that is what it is. Something the truth is really supernatural because it, whether we live or die, it doesn't matter. It's always there, right? We just happen to see it from time to time, right? So if I tell you something that you believe is true, for sure that it's always been true. It's not that it became true because I told you true, right? So it didn't become true it become true in the last 5 minutes. It's always been there. right? It's so that is what people basically say is eternal, right? Always, from end to end. It doesn't matter if we're around to say yeah, that's right, right? It doesn't need me to say that's right. It's already right. And so that's why I'm saying, you know, sometimes when you're designing these plot lines, you know, I keep forgetting that thing. There is a name for that in screenwriting people use. It is the divine, you know, bolt from, or it'll come to me later, right? It just resolves the story. Because,
Oh, Deus Ex Machina.
what is it called?
Deus Ex Machina, God from the
Yeah,
machine.
there's Ex Machina. Yeah. That's right. Yeah. In fact, there was a movie after that too, right? There was a recent movie of an AI robot, and who was called Ex Machina. I don't know. I think it's a free movie too. It wasn't Netflix. It wasn't Prime, and I'm pretty sure it's on YouTube somewhere. I think it was. It came out at the same time as you know, the other film called She or something. No, her. You know, there was another film that it was called Her. Do you know these? Do you guys know these films? You guys are doing CS2A and C++, and you haven't learned about these two films, okay? So all right. So the first one is called She or Her. You know, one of those. It's one word and it's 3 letters, okay? And it's female. That's all I know. All right. So look it up. It's actually pretty cool. It's a very nice film. Interesting, right? And the other one is very similar. I think it's called Deus Ex Machina. I don't know. I used to call it Ex Machina, right? Ex Machina. All right. Thank you, Mark. Anyway, so those are ways in which you can resolve resolve a situation without resorting to Deus Ex Machina. Just basically say, you know, take what people already know to be true and use that to resolve the situation. Then they won't say, oh, you know, I don't understand how the hell that happened. You know, you just brought something in and, you know, tied up the loose knots in your story. No, you always know how it's going to end because you know what it is. All right. Wow, there's a couple of squirrels here now. Can you guys see? So yeah, Peter, and these are not Peter or Ash, right? Those are the old timers. So these are these young ones who just started to come by. So I don't know, got to come up with names for them at some point, if I can tell them apart. Okay, all right, great. Are we all here? There's 8 of us. Okay, well, I think it's, you know, better than last class. You know, at least Turkey's here. Well, still, you know, yeah. Where's all these other people? Srikaran, someone get in touch with him, okay? Who else? Right? I'm just calling off names that I can't see here in this grid. Ryan, Elizabeth, David. Jacqueline. Yeah. Oh, yeah. Yen Yu. Yeah, are you guys like dropping off? I don't know. I'm not in touch with you guys as much as I'd like to be, right? Because we just meet for these 2 hours in class twice a week. And then, you know, I try and answer questions on Reddit, but I hardly see any activity other than the occasional posts from Turkey or Chanyi and Mark so far who have been active, right? Hardly anybody else is speaking up on Reddit, right? And that's really a pity because this is the opportunity we should take to get to know fellow programmers, right? Because, you know, in all likelihood, you guys are going to cross paths many times in your lives, okay? You may not even know, right? So after this, you like disperse like seeds in a pod, right? Bam, 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 different directions. But because you're all going to be in the similar fields, at some point or another, right? You'll have a meeting, right? Some random meeting somewhere and you'll cross paths. And so it's good to know all these, you know, your classmates. These are great opportunities, right? Because, you know, other places you may get better opportunities. If you go to a 4-year college, you may have, you know, you may overlap with the same student like 3 quarters or 4 quarters, 5 quarters, okay? But these classes like this, many at A level, many students you will not see again because these will be like samplers, right? They'll go on to do great things, maybe not in computer science, right? So they'll never cross paths directly with you. So maybe you'll meet them at a museum or something, right? It's common interest somewhere. And so, yeah, so these are the opportunities to get to know 2B and 2C, I can understand, okay, because you're going to be buried. 2B and 2C, you're going to be so deeply in your code, and you'll only come up a surface for oxygen, right? Surface for oxygen, and say, okay, hey, help me out, guys. Okay, I'm drowning. Okay, so that I can understand that. But 2A, you should absolutely, right? That's why I'm not very, not let's say, not as comfortable as I'd like to be with the silence I'm seeing. Not in class, okay? In class, you guys are, especially the guys who are here active in class, that's fine. But I'm talking about in the forums and Reddit. I don't know. Maybe it's just not me. Maybe I'm not being invited to all the parties. Okay. Maybe you're having secret parties on Discord and all these other things where, oh, CS2A students, except, not the professor. Okay. If anybody see any signs of the professor, we'll just shut down and go to another room. Okay. So if that's okay, that's okay with me, because, I don't want to impose on your time or cramp your style. But I want to know if these things are happening. Okay, because I don't even know if these things are happening, and because programming, like I said last class, it's like swimming, right? If you just attend these 2 hours, look, there's two of these guys. So if you attend these 2 classes, 2 hours each week, and then you are off after that, and not think seriously about programming, every class is just going to be, you're going to be starting at the same place, right? You'll be inching forward 1 millimeter per week. Everybody else, who's actually actively thinking about programming, they'll be going ahead like 10 miles a week. They say, well, what's the difference, 1 millimeter and 10 miles, like that. Okay, so you'll be making progress, but it won't be as high as you, I expect, wanted it to be, right? At some point, I'm pretty sure. Okay. All right. Anyway, so I'm happy to keep talking on for a few more minutes if you guys want, or you guys can keep talking. Hey, yeah, you guys can keep talking. Okay, I'm quite fine with that. I'll just see what these guys are up to. Yeah, they're actually still scared of me. Maybe. Do you want a cookie? Do you want a cookie? Look, they're actually. Oh my gosh! You see that? Oh my gosh! The little ones. They're just like less than. They're about half size of Peter, I think. Okay. Why? How come nobody's talking? Okay. See, that's why even last class I think.
I have something to bring up.
Yeah, sure. Can I just
so-
switch off, or do you want me to stick around?
Yeah, you can stay here. I mean, I want to discuss it with everyone.
Yeah.
The code for the sentence generator, don't we need to change it a little bit, because now it just only searches for a word in the sentence itself instead of actually just generating a sentence or having that as an option?
You want a cookie? You want a cookie? He just ran off. He was looking at me for a little while, but he just ran off. Tricky? Was that question directed at me, and are you expecting?
No, it's directed to everyone.
Yeah. Okay, I can answer that question. I don't want to answer that question because go ahead. You guys should feel free to talk.
Sorry, I didn't catch it.
So
Check my
in
camera.
the lucky sentence generator code that we created, we added the function that find a word in the sentence. And so right now you have to enter a word to match it if you want to see the sentence, but without it, you just get the message that you have to guess a word somehow other than an article to be able to get the sentence all done. Do we need to change it to add it as an option instead?
Yeah, I think probably. That would probably be a good idea.
Yeah, I mean, you could use, like a layer of interface, maybe.
Because if we're just doing to be able to actually see the complete sentence, you have to guess at least one of the words. That's pretty much like Hangman, if you boil it down. So, and it's supposed to be it's supposed to generate a sentence, kind of like that Inspiro bot site, where it just randomly generates a quote that doesn't necessarily make sense. I think that's more so our idea where it generates the sentence rather than, oh, you have to actually guess each word, or you have to at least guess a word to be able to see it.
I mean, I always guess the word "the" because it's always going to be one of the two articles, but it's still annoying at this point.
Yeah.
Can we add it like to one of the other arguments? Like, for example, if you add this argument or check for this kind of tag, if you want to do a search. Or maybe if you don't pass a third, like the third word to the code itself, it just guesses, oh, just run the package requested or the default package.
Yeah.
Probably just want a layer before you even do any of that, just asking the user if they want to play a guessing game, right?
Yeah.
Because, if they don't put, hey, let's make it a little more of a game than just, a sentence generator, and they're expecting a sentence generator, then that's going to be irritating.
So what are we doing today in class? Is there points we need to do, or just maybe take care with this a little bit to fix it?
Yeah, I think last class we did the class team. We can like do something like linear search or the binary search for the team class.
Okay, are you guys ready? Ready to code? Yeah, I'm thinking, well, who is it? Howie-on? You were talking when I came here. You were talking. You were saying something about team. Yeah.
Oh yeah, last class we did the team class. Yeah, no, I think
Yeah, totally. Let's take that. Let's. You know what? Yeah. Let's. Who coded last class? Chanji? Was it Chanji?
yeah. At the
I
end
think-
of class is Changyi.
Yeah, at the end of
Okay, all right. Either Chanyi or someone. Maybe Mark or I don't know. Most of you have had a chance recently. Who wants to go? Right? Just decide amongst yourself. It shouldn't be like yeah. Decide amongst yourself who wants to go, right? Because I'm pretty sure that any of you can go right now. No problems at all. And I'm thinking what we'll do is we'll take that program from last class. What did it do? It generated a name, right? Did it generate a name? Oh,
Yeah,
they generate
yeah.
team and players. Okay, let's just play with that. Let's play with that. And then let's start working around that game that we were talking about, right? Which is kind of does sorting and so on. Yeah. Well, it doesn't do sorting explicitly, but it builds up an intuition of sorting in not the programmer, right? It is going to build an intuition of sorting into the player of the game, right? So you're going to take this game that you built and give it to your, cousin or brother or little brother or niece or nephew and ask them to play it. And it's actually going to be a fun game, right? It'll be a fun game for them to play. But in the process of playing this game and figuring out how to win, they would actually have set themselves up for getting a fantastic intuition about sorting. Because I know, even today out there in the industry, right? Many professional programmers, they just use sorting, sort, right? And they knew, but how many of them actually have a real intuition about sorting, right? What actually happens? What happens in that space? How do things miraculously just fall into place, right? So because it's just one unique ordering, right? If you think about that display with effect thing that we wrote last time, Yeah, there's only one sentence, one exact sentence. That is the final version, right? Until it settles in there, everything is always in a state of flux, right? Everything is changing rapidly, and gradually, one by one, everything settles, and then you see the final form of the sentence, right? And it's very similar to sorting is like that, right? There's only one permutation that because if you take a sequence of objects, right, n objects, how many different permutations of the n objects can you get? Everybody know what a permutation is, right? No, permutation is basically ordering, right? If I have 1, 2, 3, 3 items, right? 1, 2, 3 is one ordering. 1, 3, 2 is another ordering. 3, 2, 1, right? So how many different orderings can you get with 3 items? 3 factorial, right? 1 times 2 times 3. Because with one,
It depends on if you have replacement or not, right?
the permutations. I'm only talking about permutations.
Okay.
Permutations of items, right? Not right. We're not talking about choices here, right? We have n items, and you want to permute them, shuffle them around. So how many shufflings? How many shufflings can you get with n items? Right? If you had only 1 item, you can only get 1 ordering, right? If you had 2 items, you can get 2 orderings. Yes, you can have this or that. If you have 3 items, what do? Right? So now here's the computational way of thinking about it. You know, and I'm glad we actually started talking about this today, because this all ties into computer science and the way that we build programs and so on, right? This is permutations. I'll come back to this in one sec, okay? In the meanwhile, if you still have anything interesting to say or share about permutations and orderings, please go ahead and do it, okay? Hey, do you want some nuts? Okay. Here, you can finish off the. I've been wanting to. Oops. Here. Yeah, you can have that. Yes, the bottom of the walnut pack is full of walnut meal, and it's also powdery. So I don't know what's going to happen. Okay. Yeah. So permutations. So three items, right? So so the computational way of thinking about it is to say, well, I can do three I can do painstakingly on a piece of paper. 1, 2, 3. Well, one, then flip those 2, right? And so on. And in fact, everybody should do that on a piece of, if you have never done this before, right? In fact, everybody should have done that in school, right? In about 6th or 7th grade, everybody should be forced to do that, because that's how I think. I never should say, should, right? No, I think it would be really nice if everybody does that around that age, because it builds up a way of thinking about problems, right? Because it lets you notice the pattern, right? It says, well, I have 3 things now. So if I hold one of them constant, then I only have 2, right? So those 2 I can flip around in 2 different ways. Now, for each of those 2 different ways, I can change this to the other guy. So essentially, I have 3 times 2 times 1, right? So if I have n items, you'll see the pattern. It is n factorial, right? So that is the beauty of it. Now, once you know that, that is how factorial happens, right? That is the intuition behind factorials or permutations, orderings. It's like, if that is intuition behind factorials, now I can see that there's a pattern, so I can turn it recursive, right? So then you start thinking about factorial as a recursive function, because now no matter what big function you give me, I don't have to do it on paper, because I can do it in a kind of recursive way, apply the same logic over and over again to a smaller and smaller number. All I need to do is multiplication, right? And then when you start thinking about it, say, how can I make it even faster, right? So I don't need to have, this, was that recursion? I can make it all do it in an iterative way, and all these things start bubbling up and at the right times, and that is why these are ordered. So coming back to sorting all the way, right? And I'm glad we're talking about sorting and all. Sorting is such a incredible thing, right? Because if you take n items, how many possible orderings can you get with n items? It's bigger than exponential, isn't it? Because it is n factorial. Right? So if 3 items are 6, 3 items, 6 possible orderings, right? 4 items, 24 orderings. So if you have a huge number of items, so if you have 69 items on most of your calculators, right? This is what we used to play with back in the day when we didn't have computers, but we had calculators in college, right? So we used to calculate 69 factorial because that's the biggest number that your calculator would show before showing the arrow sign. Because in the internal data representation it used, that was the biggest double precision floating point number, but not, I shouldn't say double precision, highest precision floating point number it could represent. Anyway, so that is why the sorting is so incredible. If you take it elsewhere and sort it and bring it back, it's a different story. Okay, that's why there's something to be said for merge sort and all these other things, right? But they're not as miraculous as this is really miraculous as in-place sorts or even in-place algorithms, because in place is you're looking at it. It's like David Copperfield, right? David, you watch David. So everything is happening right in front of your eyes. You can see there's no way things can go wrong, but yet magic is happening right there. Right? So how many you've had that feeling, and that is the feeling you get by looking at in-place algorithms, and because you want some incredibly sophisticated thing to happen, and you know for sure that this incredible thing can happen if I just divide and conquer, right? If I break it down into 10 parts and give it all to these different people who are all experts, they'll bring it, they'll do it however they want to do it, and they'll bring it back to me. All I need to assemble it together, right? So, okay, that's one way of doing a high level picture, right? And it works, but you don't know the nitty-gritty details. So a lot of magic happens, but the magic is basically chopped up and compartmentalized into black boxes that you don't see. Right? So what you get is just hey, welcome, Elizabeth. Okay, we're just talking about a program that we wrote last class. We're going to pick it up and modify it today, right? So what were we talking about? Yeah, magic, right? So the sorting, the magic is happening still, right? Even if you do merge sort, even if you do distributed sorts, parallel sorts, right? Map reduce sorts, all kinds of. The magic is still happening. The only difference is that if it's not in place, the magic is happening elsewhere, right? And so you don't get an opportunity to see it. And so that's what is so incredibly cool about in-place algorithms, especially quicksort, because if you go to, I don't know, if you go to Wikipedia, Quickie-Mart is the Bart Simpson thing, right? So Wikipedia. So if you go to Wikipedia, I'm pretty sure they have an animation of quicksort where, you have this array and these things just fall into, hey, actually what, Lane Johnson did a video. Lane Johnson, who's our tutor in the STEM Center. I don't know, have you guys met Lane Johnson? Have you been to the STEM Center? Tutor, right? This is free, 24 hours. We have top-notch people like Lane Johnson offering services for free, and you should take advantage of these things. Anyway, he did a really cool video demonstrating quicksort using letters, English letters, ABCD, right? Animated like claymation, right? He did that, and he put it on Vimeo, and I shared that. In both the spec, because my 2C students have to implement quicksort, right? So it's in the spec, but I also put it in the subreddit, in the CS2C subreddit. You can search, right? Is it probably first 4 or 5 posts? There is a video that, and so it's nice. That's why people also like to animate these things and show it to you, because when you have an algorithm that's happening and it's not being parceled off somewhere else to get done, you can actually see the magic happening right in front of your eyes. And so with n coming back all the way to sorting is so cool, right? Because there's n factorial permutations, but there's one magic permutation that's we're after out of n factorial. So it's not even an exponential problem, right? Think about it. This is a super exponential problem. Exponential is 2 to the n or something like that, right? N factorial is even bigger than that. So we are being asked to literally find a needle in a haystack. When someone says, here's an array, a big ass array sorted, right? They're saying, here's a haystack with, a ton of possible permutations, and there's a needle hidden in there. Find it for me. And the algorithm is the magic by which you can, and so you can actually see the magic. So if you went to a David Copperfield show in Vegas, right, and you can't see anything, right? I bet if you told David Copperfield, okay, David, right now, I just want to have a super high def camera covering everything here in infrared and all kinds of light, and we're going to slow it down to a billionth of a second, right? I want to capture that and want to study that. I'm pretty sure we'll find out. Everybody will find out eventually, right? Including everywhere. All empirical phenomena, measured. We'll find out, but then so that where was I going with that? Sorting. Yeah. With these big things happening really fast, it'll look like magic. Yeah, that's right. Things happening really fast, it'll look like magic. So that's why the smaller arrays, smaller problems are important in computer science. Because people always say, I'm going to solve this big problem and do this big problem, right? No, you can't solve the big problem until you have an intuition about how you're going to solve it, right? I mean, you cannot get an intuition about how to solve it looking at the big. So because the intuition is exactly the same, just like in factorial, or any other recursive program, the intuition is tight, 5 lines or 6 lines, and it's right there. And then you just apply the same thing at different levels, and so yeah, sorting. And so that's what I mean. Going all the way back to what we plan to do today is that this game, I hope, will eventually, you should be able to wrap it up in JavaScript, or even wrap up some open graphics or some library, and add some bells and whistles to it. And I'm pretty sure this will be a good game for kids to play, and also develop a really, really solid intuition about sorting. And then when they're actually introduced to computational sorting, right? Because computational sorting is different, right? So lots of people out there didn't know. That's what I mean, going back all the way, right? So it may use sorting, but they don't have a solid intuition about sorting. And it's a pity, right? Because they need to, having a solid intuition about sorting is really nice to have. It's fun to have, because you can actually see this happen. That's where all that magic nonsense was about, I guess. All right, so what we can do today is someone can take the screen, and then let's pull up Chanji's code from last class. We'll use most of that class, and then well, actually, I need to see what that code is, I guess, because I know it made a name, and then it's this team class, and then when we see the code, we'll get more ideas, right, about what to do, and then you guys can call out ideas too. And then we'll just code, right? We'll just code. I think the best code we've written so far has tended to be code where we just code, right? Off the cuff, really, going with the flow, what you guys want to do. And generally, so yeah, go ahead. Why is nobody now picking up the screen? So someone should pick up the screen and start an editor. Who is this? Chanyi, okay, thank you. So we're going to just keep going with Chanyi's code. All right, so let's take a look at your code. And by the way, most of you have dropped off my screen right now, right? Well, I only have a MacBook Pro, so I've got like 4 people on the side, that's all. All right, so we got, where's the team class? I want to see the team class, thank you. See, what do we do for team? Team.h, sorry, team.h. It's in your package explorer, yeah, team page. All right, so we have a default size, max team size, and then we have set player name. Oh, we have player names. Okay, player names. Okay, how about this? All right, how about this? Here's what I'm thinking, okay? In the team, is this a team class? Okay, this is a team class. And you guys should tell me if I'm wrong, or if we can do it better, because we're going to do it according to the way that we have collectively identified as the best way to do. Okay, so if you agree with me, that's fine. If you don't, tell me, right? So we can change. So currently, Chanyi, could you please highlight line number 12? Yeah, line number 12. Okay, yeah, yeah. So on that line, we're just declaring in this team, this is a set of players, right? So I'm thinking we'll do 2 things here. No, we shouldn't conflate things. Okay, so what I was thinking before, and I'll tell you why that's wrong. Okay, and then we'll going to refactor the structure of this idea slightly, and you'll see why that's better, I think, hopefully. All right, so previously I was thinking, well, the team has a bunch of players, that's a vector string of players, but it also has a pecking order, not pecking order, what should I say? Ranking order, right? So it has a ranking order for the players, right? Player 1, player 2, and so on and so forth. These best player, worst player, right? 10 players. So it has that. So I was thinking that should be part of the team itself, so that we have or the 2 vectors, right? We have ordered players, which is, yeah, in fact, that's what we should do, right? A team should basically have a vector, player names. We should change that. Let's double click on player names and right click. I want to see if Visual Studio Xcode. Does it do rename? Oh, it does rename in C++.
Xcode, yeah. Xcode.
Oh, okay. Yeah, click refactor. rename. Wow. That shows you how long I haven't used Xcode, right? Because the last time I used Xcode, I tried to use rename and it said no rename. You have to use Objective-C, all right, or Swift. I change that to sorted players, okay, sorted players, underscore sorted players. So what we're saying is that this team consists of a vector of players. Not only is this a vector of string names, but they're also ordered according to ability. That is what this one line means, okay? What we've done there is just by changing the name of the variable, we avoided the need for a comment, an explanation, and things like that. So hopefully this should be clear that one variable has two things in it. It has the names of those players as well as the ordering information. Is that clear? Okay, all right, so that's how, so we saved ourselves a comment there. Okay, great. Now what we'll do is that, so that's our sorted players. In our make musical names, set player names, in our set player names function. No, you don't need a, oh, I see, you want to put a comment there for students? Okay. Contains information, contains because this is one thing, contains information contains information. Oh, well, basically, get rid of the information, right? This is all written. It contains names of players as well as their relative ordering, as well as their ranks, as well as their implicit ranks, because you're not explicitly specifying the ranks. The ranks are basically the array indices. Ranks, and say implicit within parentheses, ranks within parentheses, and then move that comment to a previous line, and so that it's all cleaned up. Okay, so yeah, that's fine. Ranks, and then put a parent within parentheses, say implicit, space. Yeah, you want a space before the parentheses, right? Now take that entire comment and put it on the previous line. Yeah, and then blank line after that. Yeah, blank line after the two variables, and then this vector can be there, and then attach just the vector to the previous comment, and then you can start the Great. Next line, please. Thank you. All right, you can clean it up later. I think it doesn't look so good. Maybe you need to jump, I don't know, maybe it looks good. Okay, all right. All right, great. So is everybody okay with this so far? So every team has a bunch of players. Each player has a name. So what we want to do now is, here's what we want to do. And you guys, I can show you how to do this, okay? But I would prefer, even if you take like 1.5x time, right? So even if you're not going to do it at 1x time, if I was talking to you, maybe you take 1.5, it's worth it. It's totally worth it. I can even basically just step off if you like. I want you to take a crack at this, all of you together, not just Chanyi, okay? Chanyi will have to fade into the background, okay? So Chanyi, what you should do is don't type anything that comes into your mind. You're just going to type what someone else calls up. Right, so I think David or someone else, Ricardo, not Ricardo. It was Ricardo's gone. David, who else was typing sometime just a little while ago? Chris. Yeah, I did that. Chris did that. Right. Is that okay? Someone will just call out the code. Good. All right. So here's what we want to do. Okay. So in the go to the place where you define the set player names function. Set in. I think it's in team.cpp. Okay, here, okay, good. So here's what we want to do. Notice how we have this one loop and it's really tight and everything happens bam like that. Yeah, okay. Now, the problem here is that two players could have the same name. Well, strictly speaking, that's possible, right? You can have two Bobby Juniors in a baseball team, yes? Right, but for the purposes of the game, it's going to be messy, right? Because you'll have who's better, Bobby or Bobby. So, so what we want to do for the game, thinking a little ahead, is that let's try and prevent the situation where two players have the same name. Is that okay with you guys? Okay, all right. So here's what I'm thinking. And you guys don't have to do it this way, but I think this is a reasonably clean and easy way to do it. So before you add the name to your vector of names, right? You are going to call some function, maybe a utility function. Right? Or you can do it inline, but it'll actually look better if it's a utility function, private static utility even, right? Given a vector, given a string, is the string already in the vector or no? Right? So what you want is basically a static utility function, which takes two parameters. It takes a vector, a constant vector by reference, a constant vector of strings by reference. You got, if it sounds like I'm the only one talking, I'm going to minimize the window, okay? Because I'm not looking at the code. I want to look at you guys now. Give me 1 sec. Okay, all right. So I need some feedback here. I need to know that everybody's on the same page because I can't feel comfortable stepping away. Okay, so I need, right? Because Chanya is not even going to, she's just going to type. Someone else has to think through this and type, and maybe Chanya, say, hey, is that okay? And so on. That's fine. Okay, but you can't come up with the code yourself. Okay. So tell me if this is okay. In that function where you, yes, someone had something to say? Okay, all right. So in your code, in that making your name, every time you're going to make a name, you're going to write this utility function out there that takes 2 things: a vector of strings by constant reference, because you're not going to change it. And then it is going to take another string to that target string. Let's say string, right? Target, right? Those are the only 2 parameters. And this is going to return true or false. That's all. Bool return. When will it return true? It is going to search this vector for that target string. The moment it finds a target string in that vector, it returns true, right? It doesn't matter. The vector might be 1 billion elements long, right? And the string you're trying to find is the second string. So you're not going to look through the entire vector and say, well, I've searched through the entire 1 billion elements, the string is not there. No, as soon as you find it, return true. Yes? Okay, so that's the reason I make such a big thing out of it, is that it is so, we all say it is so, right? Always end up, most of the time, if you're really, really careful, even code that you think is really squeaky clean, if you go back to it, you'll find that many times in many places, we're over-solving problems, right? And in fact, you can, when you start working in a company, this is a cool way to, get some bonuses, is look at old code that people have written that has been working for, it's working code. And you can actually look at, it's working, that's fine. Nobody's complaining because it's working, but it's actually over solving the problem. So let me just solve it, just a problem, right? And then create some gains, right? So lots of people do that. And so that's all you have to do, right? So you don't, many people make the mistake saying, oh, I have to go to this company and look for new projects and make my name, right? So you don't have to always find new problems, because people have done old projects in inefficient ways. You can always improve on those. Okay, so here's what we're going to do. What was I talking about that? So essentially, you're going to call that function, and that they're all constant, right? And so you're going to say yes or no. That's all. Yeah, oversolving, right? So don't oversolve the problem. As soon as you know the answer, return. Whether it's true or false, as soon as you know, return. And now it seems so simple, right? Many times, here's the funny thing, right? Many times later on, why people oversolve problems? Because they can't see, right? They can see that they oversolved. Why is it? And many times I found that the reason is because the situation where you can tell that you're done is not very straightforward. In this case, it is so straightforward, right? So you have a vector that's 10,000 elements long, and the element you're looking for is the 3rd element. Then as soon as you get the 3rd element, you're done, right? You don't have to look through the remaining 10,000 minus 3 elements. Yes or no? Right? So in this case, you're able to return only because you're done. Yes?
Yeah.
Okay. Now, so and a lot of people don't, I don't know, right? The thing is, the subtlety there is so important that we overlook that, because in this case, it was so easy. We're so lucky. We're so lucky that the termination condition was staring us in the face. Okay. And it is not just looping, it is everywhere. Iteration, it is in life, right? It is life. Because even in life, if you don't know if you've got what you want, you're going to keep slaving away until you die. Right? So the important thing is to know when you've got what you want. And if you don't know, that's what I call knowledge of poverty, right? So people who don't know what it's like to not have what they want, or what they have, that thing is pretty much invisible to them. If I have an iPad lying around all the time, the only thing I'll know is when the iPad is not there, right? So oversolving the problem, right? So in this case, it is easy. I can see, I can get out of the loop. I'm done, right? So many times.
Professor, can I ask a question?
Yes, thank you, Liz.
Like I totally get that we know what our stop condition is, but it's kind of hard for me to think of a concrete example of what you mean, where where the place where we're supposed to stop, where that would be unclear to us. Can you give me sort of
thank you.
maybe what we
for any
encounter in the
name there. Yeah.
professional world.
So this case, and here's a thing that you can watch out for. I think it's a very clear signal, right? So anytime you say, well, if this is true, I'll go, right? If it is false, if you have to make a break from a loop or return on a false condition, that I think in my experience results in, I think, a higher chance of overlooking the termination condition, right? So you may look for something else. So I think we are more prone to breaking out of loops on something true rather than something false. And so we're always looking for some true condition before we break out of the loop. But we should be able to say that, you know, if you're trees and lists and sorted arrays and so on and so forth, especially quicksort and so on, right? Searching, binary search, we should know that the element is not there in this vast tree starting at this node. Many times students make the mistake of saying, I don't know that the element that I'm looking for is not in this vast tree. So I'm going to look at every node, and only if every node tells I'm not that element, right? And only then I'm going to return true. Yes. Many times we don't know, but if we use information that is encoded in the tree, so this encoded in the tree meaning implicit information, that's what I mean, right? In this player, and that's why this vector that we use is really cool, because it is a vector that stores two things at the same time. It stores the names of the players, right? But the other thing it stores is not visible, it's invisible, right? It stores two things. It stores one visible thing and one invisible thing. Yes. The invisible thing is the ordering of the players. But someone who just looks at the vector will only see the names, won't see the ordering. So it's implicit information. So like that, when it comes to, you know, that's just a linear one-dimensional structure, right? But the same thing happens, whether it's two-dimensional or three-dimensional or k-dimensional structures, right? Exactly the same thing. Because, you know, same logic you can extrapolate to KD trees, right? K-dimensional structures, multi-dimensional, right? So you can say even in continuous space, right? Even continuous, because how else can we deal with continuous space in mathematics? Right, so we are used to dealing with countable numbers, but how do you find something in continuous space, right? So you can do that by using sections. That's why you use intervals in continuous space, right? And so that's the error that lots of people make, especially I don't know here. Yeah, it's starting in Quest. And when you have to compare floating point numbers for equality, right? When you have a floating point number and you want to break out of a loop, if that floating point number is 0, right? And this happens all the time, whether it's Python or JavaScript. Happens all the time. So I think it's a very general example. You cannot compare a floating point number to 0. Yes, because lots of people, and that is a false condition. It'll never equal, because, you know, floating point numbers could be 0.00 and it actually shows up as 0. So the only way you can break out of a loop on a floating point check is by checking for a threshold. You have to check for an interval. Is it greater than 0? Does it fall under this floor, right? So you have to check for intervals. And so if you do these sections, then you can do these really fine cuts in continuous space. And that's how we deal with it, right? So just like that, you know, the tree structure, k-dimensional structures, right? So they're still discrete space. A discrete space is just the same as rational numbers. So it's still countable. So if it's discrete space, you can basically use implicit ordering information, which lots of people don't see, all right? So if you take a tree, a binary tree, or a heap, right? A heap, right? In quest number 8 or 9, or one of those. CS2C, right? So people have to take a heap data structure and then convert that into a sorted vector, right? So it's really cool that that problem exists in that quest, because there is ordering information already present in the heap, right? I know we haven't even talked about heaps, right? A heap is a special way of storing data. Okay, it's like it's an ordered structure. So, but it's stored in a certain way in which only if you know the ordering, the way in which the heap is stored, you can find the ordering. Otherwise, it looks like a jumbled mess, right? So someone who looks at it will just see as jumbled mess, but someone who knows the ordering will actually see a heap ordered 1, 2, 3, 4 like that, right? So when I say to someone, here's a heap, you know, turn it into a sorted array. Someone who knows the ordering information will basically say, here, 1, 2, 3, 4, 5, 6, and they just do it in linear time, bam, 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 like that, right? Someone who doesn't know is going to take that and do some log linear algorithm or something like that, okay? So the trick there is to recognize that what we don't see, right, usually has a lot more information, a lot more useful information for us than what we do see, right? And that is the reason in many of the quests that you see these error messages that are really, really cryptic, because most of the time, right, if what you see doesn't make any sense, then what you don't see is where the answer is. Okay, so I don't know where we're going with that, but yeah, sorting. So that's Elizabeth. Does that answer your question? Because sometimes in a tree, when you're searching a tree, you have trillion elements down this one node, right? One node branching into a trillion element tree, right? And you need to know if a number is in that tree. Sometimes, but the information about the tree that you know, that you already know, lots of people forget, right? If you know that tree is a binary tree in which the left node is always less than the root node, then you know that if the element you're looking for is greater than the root node, it's never going to be here on the left side, even though the left-hand side is a vast universe of trees. Yeah? Yeah?
So I think for the second variable there, you
Can
might
I
want
go
to
back to
use
the
like a temporary variable. Otherwise, you're almost guaranteed. I mean, you are guaranteed to have the variable in there, right?
Oh, hang on. Oh, are you actually doing that now?
Well, I proposed something in the chat that like.
Oh, I didn't read the chat. I'm so sorry.
Yeah, no, that's fine. I was just thinking, so first thing you would want to do is set up a temporary variable that would fill with
so that's a
the
string,
proposed
isn't it?
name.
A string, your temporary variable.
Oh yeah, it'd be a string, duh.
So make a string. So we'll make all those errors go away.
Yeah.
Hey, I shouldn't be talking with this. I'm sorry to butt in. Mark, do you want to talk Chanyi through this? Yeah. And by the way, I didn't complete that, right? So it's gonna do that linear search, right? For now, it's just gonna say, is this target in here? If it's there, there's two ways you can do it, right? It's one way.
Yeah, hey, on the line 25, the first thing you want to put is string before the variable name. Yeah, right there. And then on line 26, the second thing in the parentheses, you want to put temp var name. That's the first thing. The second thing is underscore. Right now it says underscore sorted players I. That one right there. Just replace that with temp var name, and I think that would fulfill what the professor mentioned. And because it's just a plain string, you don't want the I. Okay. And
Great.
Depending on the logic of check double, which in retrospect we should probably capitalize the D on check double, just to have like camel case or something. I think that would be sufficient, depending on the logic of how we set up that function. That said, we should put all of these in between brackets. Like at the end of line 24, you want to have an open bracket. And then after line 28, you want to close bracket. Okay, how's that look?
May I ask what is this means? Check double.
So that would check the vector and assorted players for whether or not the name created in the line above it is present in or already present in the array. And if it is, it would probably return like a, hey, do it again. So we might need a while loop in the logic at some point, depending on how we set up check double. Does that make sense to everyone? Okay, cool.
We just need to, this is a declaration in line 26. I think we just need to move the vector string part till the ampersand, right?
Yeah, I'm not 100% sure what you said. Sorry, what?
Oh yeah, so we're gonna declare this function later on in the header and make like within the team, right?
Declare the function in the
Is,
header.
Is it gonna be like declared in the header, the teammate.h?
Yeah, we would have to
Oh.
set up the logic on that one, and it's
Oh.
going to involve, just looking through the vector for that name or if it's there.
I see.
Although the code is saying that we have a whole different kind of error.
Oh yeah, because the function doesn't exist yet, and we have the vector string part till the %. This is a declaration, and you're just trying to pass a value. So like in line 26, from the vector part after check double, all the way to the %. Just
Oh, okay, cool.
So does that mean we need to define the check double, or we need to define the vector?
Check double in particular, I think the way that we define it is going to determine whether or not it's passed by reference. So we might not need the ampersand at all, or the declaration of vector string. Like we could just delete that entire section, like Turkey said.
You mean delete this whole vector string section?
I think that's what you're suggesting, right, Turkey?
yeah, wait, is it check double gonna be a value, or is it gonna be a function, or they're gonna declare it?
It'd be a function in this case.
So in this case, we need to, like, you're just calling the function, so we don't declare a value when you call a function. So yeah, all down.
Okay, yeah, that makes sense. And now the error that we get makes total sense.
So it will be void, or for the check double?
Great.
Depends on how we want to implement it. Do you think we should have it return a 0 or 1, or do you want to?
Maybe a bool.
Yeah, I think a bool.
false.
So this would be vector and this is where we have the data type declaration in the inside the parentheses.
Data type declaration.
Yeah, so like on line 32 inside the parentheses in the first section, you want the open or less than, greater than, and then inside vector.
You mean declare the data type here? Sorry.
Yes. Well, I'm probably using it incorrectly.
Like a vector, then the type of the vector. So vector string at this point. No, string in between the,
String.
no, a vector at first, then between the thingies. String.
Yeah, and you're gonna want an and for underscore sorted players because we want to pass by reference. And then the second one is going to be a string, I'm pretty sure.
And declare the class for the function. So at this point, it's team.
Oh yeah, duh. It's got to be inside the class. So probably want. So before check double, we put team and then 2 colons. And you're going to want to do that on line 26 as well.
I mean, if you call in a function inside the same class, do we need to call it team, or I don't think you need to call it team because it's already in the same class.
Oh, okay. I was wrong. And then the logic for that function would just be to, I guess you could use a for loop to iterate over the element of sorted players. And then if the element of I equals temp var name, return true, else return false. Or outside of the for loop, you would return false. So int I equals 0. Oh, okay. I less than what are we using to get the size of sorted players?
Maybe the length of the vector.
Yeah, that'd
Let me
work.
check. Would that be length or would it be a different thing?
Do I need the in person here?
Not in this case, I don't think so. But it's saying that there's no length.
Let me double check how you
Or wait,
define the length of a vector.
looks like it's
Oh.
okay. Oh,
At
no,
this
it
point, we
isn't.
look at size. In vectors, we look size. I think length.
Yeah, let's try
is-
size
I
instead of
see.
length. And then if underscore sorted underscore players big brackets I.
Like this?
Yeah, equals temp var. Oh yeah, equals temp var name.
Fair name.
Sorry, temp var name.
You mean, what is the fair name?
So
10 fair name.
instead of 10, it would be temp var name. Yeah. No, it's because
Heard.
I'm mumbling. Return, I guess, 1. And then outside the for loop, return 0. But you'd probably want to break after the return 1, now that I think about it, just so. But it has to be in the scope of the if. So we'll have to put all that in brackets after the if, yeah. But the way this is implemented now, we have to consider the 1 or 0 condition in line 25. Yeah, so. Just thinking about how to implement it. So I guess after 20, like on line 26, you could declare a new bool.
Declare new bool.
Yeah. So just bool doubles check maybe.
What if we do it inside an if function instead?
Yeah, if you want to take over and explain how you do it, go ahead, because I'm kind of just.
The function you guys did, the check double, like the check double is perfect. But I wonder why we have a break.
That's because if you do have a match, you want to get a new, you want to iterate the for loop again. But if you don't find that, you want to return 0. But if you do have a match, you don't want to return 0, right?
Yeah, but I don't think it will return 0 ever. I mean, if it's a match, it should return true that it exists. And if it's not, it should just finish the for loop and just go to 0, just go return 0.
Yeah, like on 39.
Oh, so you think if it returns 1, like the loop won't break? I mean, does it?
Oh,
So,
yeah, I'm just not
No.
100% familiar how the logic would work without the break, but yeah.
I was
if
wondering
that's-
if the for loop going to continue going if it returned 1. Like, I don't know, maybe in the back.
Yeah,
Um,
I'm not 100% sure myself.
But yeah, we can do it like
If you don't think it's going to keep going, then kill line 36 and 37 and then take it out of the brackets.
I'm really wondering if it goes.
Yeah, and I think about it, when it returns, it tends to terminate the for loop, huh?
I don't know. I'm checking. It will be very interesting because if it returned it, that means does it continue and check for another value and return 1 in the background for some reason?
Yeah, keep printing 1.
Yeah, I'm gonna ask Professor about this because that's interesting. But yeah, if we do it as an if function, so if check double in line 26.
If check.
Yeah, instead of bool, just say if check double.
Yeah, I was going to put like a dummy variable to work on, but if implementation would be a lot smoother, that sounds good.
Then what we should do if it found a double, should we just like reset the clock of the random maybe?
Reset the clock.
We do rand s.
You
So we
mean?
can just
I'm a little bit confusing about the if here. What is?
So it would be if check double equals 1. So at the end of the parentheses there before the semicolon, actually you might want to get rid of the semicolon. Wait, hold on, no.
No, we can check the value because regardless what it is, it will just return a 1. So a 1 is a true. So if check double this values, because you expected a boolean out of the function regardless, so it should be if this true, then we should.
Yeah, so after check double, just delete the stuff that's between, oh wait, undo, Control Z. So you had it, actually just Control Z a bit more, a little more, a little more. There you go. And then delete the semicolon at the end of that line. This is where you want your equals 1.
Oh, I see.
I don't think we need
Yeah.
the equal.
Wait, okay.
Because it's returning true. So it's returning true. So technically, if you say if the function, so you don't need to double check the value that's returned.
Oh.
So technically, it's like saying if true.
So
Right.
basically, I don't need the equal 1.
No, you don't need that.
I see.
And yeah, that works. Then continue the F. What should we do when it's true?
We want to rerun the temp var name declaration on line 25, basically. So that's why you might want a while. So maybe while equals true. No, I mean like instead of if. What do you think, Turkey?
So what should we do if it's true? Should we like create a new name, or should we set that value to a different thing?
We could actually just redeclare 25 without the string. So while instead of if, and then just copy and paste 25 onto 27. And then delete the string so it doesn't throw an error. Does that make sense? So as long as you return a 1, it'll redeclare the temp var name calling that function.
And I'm just trying to follow here. Step.
Well, I'm not quite understand.
It might not work in C++ because this is kind of a, yeah, it might be a Python sort of implementation that I'm considering. But basically, if the check double returns a 1, it's going to run line 27, which would redeclare the temp var name, which should give us a new name, right?
It should, yeah. Well,
Then if once that's done, it'll recheck the while loop, which will call the check double function.
yeah, and once that name doesn't exist anymore, it just breaks out, and that temp variable name is a new one. I think
Hey.
I think it is correct. We can test it. I mean,
Yeah. I mean, I feel like we still need to declare this in like the header file or something before
Yeah.
it gives us some, before it stops giving us an issue. So we'll just, I'm not even sure where we would declare it.
oh, team H in the team H file. And
In the public?
I think because it doesn't have, we didn't add underscore, I'm just gonna say, yeah. Without the declaration of the team, of the class. We declared the class and check double. You see the team, that's a class, so.
I see. Thanks.
And come on, semicolon. Should work. Nope. Oh,
Maybe 33 through 41 has to happen before 22.
yeah.
Huh.
Oh, it's gone.
Great. Okay, maybe this will work then.
Oh,
we
yeah,
might need std
in-
vector.
In I
Header
think in the header file.
file.
Because it's a string and we don't have the declaration here. So before vector string,
Vector.
Line 27. Yeah.
just add the stds to double quote.
Oh, I see.
Oh, the string part, string temp var name. They need the same thing. The second variable.
mean like this?
Not here. The other one. Look next to it. There.
Oh. But this is the string that it's.
Do we
under-
do?
Yeah, that one should be good. There was the other one that was thrown in error.
Does it? That's interesting. I'll double check.
Oh, I think that's going to give you an issue. Okay, it should build though.
But I renewed the wording is still here.
Yeah, I'm checking how it's supposed to be. I'm pretty sure.
Oh, you know what?
should-
Maybe the STD needs to be inside there and not the very beginning of the line, like you were suggesting, Shani.
Oh, there
Yeah,
you go.
that looks
Yeah.
better.
Uh,
Both.
I think it's both.
Oh, that's just awful. Oh,
Wait,
that's right, because you got vector.
Oh, in the declaration, maybe? No, no, it's not.
oh, succeed.
Well, the build just worked, so I think we're okay.
Nice.
Yeah, Nand, I think we just finished implementing that function you were talking about. Do I have to declare a Nand with reference? And just making a check.
I don't think we need the declaration for team in line 37. Or do we do declaration inside functions? Oh yeah, we call it. Oh, never mind. I see. I think we need to do the same thing in our function backup so we can make our code look.
Although technically we can't really check until like we feed check double an intentional like double.
Or maybe see
But
out
it should
double.
just work, you know. Hey, Anand, are you there? Well, I think he mentioned that I guess the next step would be to sort the names, but I mean, would we do it alphabetically or phonetically? What do you think?
So alphabetically. That's, I mean, how can we sort it phonetically?
Well, I mean, you've got do, re, mi, fa, sol, la, si, do.
Oh, I see. Okay.
So you would
Yeah.
consider,
Do as the first one.
yeah, but potentially if you wanted to sort it phonetically. Because I think some of those don't follow alphabetically. I could be mistaken. But sorting it phonetically sounds like a massive pain that might take longer than the remaining, what is it, 40 minutes we have until 10 o'clock?
Let's try sorting it alphabetically. Then maybe we can find a way we can do it the other way. I mean, if they can go like this, they can go like this. So we do make a function called sort.
Yeah, I would probably make it a void function. What do you think?
Yep, because I mean, is there anything that can break the code? Because other that
Yeah, I think, but I'm not quite sure about how to do it. Honestly, there, it might be able to.
Well,
I mean,
since the
declaration.
ASCII values of the letters are ascending order, you could.
Do we count it as D, like DF, or do we call it like the numbers? If we assign the numbers.
I think it'd be easier to use the ASCII values, or at least consider them in the sorting algorithm.
Okay,
Since,
so
I mean,
let's do a void. And yep. And call it maybe,
Would it be a private or public then?
I think we should make it private. no one should be able to sort or control the sort of it. Sorted or sorting. I don't know. We take a vector value, the vector value that we pass by, and we make sure that
All right, I'm back. If you guys would like, I can review stuff that you've done before, if you want, right? And then I'm not looking at it yet, okay? And if you prefer, I could toss around some ideas to refactor that code if it needs refactoring, or if there is possibility of refactoring it in a different way so that you can look at two different styles, and right?
I would appreciate feedback on how I implemented that
Yeah.
the check double function
Okay.
personally.
Do I have you guys permission to refactor this code? Okay. All right. Great. All right. So let's take a look. I'm going to shrink the. I'm going to shrink your gallery a bit. Just give me one sec. Okay. All right. Most of you dropped off now, but I can see the code. All right. Great. So that's the code you wrote. Okay. Set player names. All right. What is that sorted vector string below that? 43, 44, 45. What is that?
That would be the sorting.
Oh, no.
function.
Sorry, I'm sorry. Maybe we never got a chance to play this game. That's why it's this confusing. Get rid of that function, because we're not going to do sorting in this game, right? We're
okay.
going to let the player do the sorting. Okay. So as the kids, like, your 7-year-old cousins or, nieces and nephews, they play and they're going to sort the stream of vectors, even without knowing they're going to sort. Okay. So that's the fun. Okay, cool. So let me take a look. All right. Check double. Okay, so here's one of the things that I might do, right? Even though check double is a utility function. Now you guys have to correct me if I'm wrong, okay? Now, is it obvious to you, or can you guys all see that check double is basically a utility function? Yes or no? Yes, okay, all right. Now, what does this utility function do?
It looks in the array and then sees if the name that you're trying to come up with is already in there.
Okay, good. That's all it does, right? So from the perspective of this utility function, does it need to know, right? So you have to think carefully about this, because this is a question you're going to ask yourself a million times. Does it need to know whether the function is part of the team class or not in order to do its job?
I don't think.
No, right? No. Great, fantastic.
I totally
Okay,
missed what
so
you mentioned.
let's do something there. Let's do something to this function to refactor it very slightly so that intuition is now reflected, right? So we know that this is not going to be used outside of team, and it's not relevant to team. Whatever it does, it can do to any vector, right? It can do to any vector and any string. All you're asking is this string in this vector. That's all you're asking, yes? Okay, so technically it doesn't care about teams and players or anything. It just needs a vector and a string. Okay, so what we'll do is try and make our design reflect that notion. So we will change the name of this function. We were going to do a few things to the signature, but let's just change the name. So double click on check double, and rename. And let's not call it check double. And also this time we'll also follow the convention in the rest of the code, which is camel case, not snake, which is snake case, not camel case. Yeah. Okay. So let's call it vector contains, right? Vector contains. Or you just say contains, or just say team colon contains. Just say contains. Team colon contains is actually much better, because now so we're bringing to bear a number of things about this domain that we know, which is implicit, and it will ease the task of yourself in 10 years, or someone else, some other programmer looking at it. So we're going to name this as a predicate because it is a function. It is going to return true or false. Yes, it's going to return true or false, which is a predicate. And therefore, this should be named as a verb. What was it called before? It was called check dupes. Well, that was also a verb, right? But contains is also a verb, which is more straightforward, but it's not particular to a vector that only has duplicates, right? It could have triplicates. It basically has contains, right? So contains also, the other reason for using contains is you'll come to know that contains is standard, right? Even, standard library people, when they create a data structure, you can bet your ass there's going to be a contains function in there, right? So most of these guys, unless the contains function is not straightforward, right? Sometimes straightforward, because if a function is not straightforward, they will not give you a standard library, will not give you a function for that, right? Because it may be a linear function, it may be a quadratic, a highly complex function. And if it's just one word, people who don't know, most of the programmers who think they are programmers, they don't know what they're doing, right? They just see something that's 4 letters long, they'll use it, right? It's 4 letters long, but it's actually doing some exponential thing on the other side. So they won't surface that to you, right? If it's really simple, and if anyone can use it, then okay. So contains is a much better way to use that. And unfortunately, in this case, however, I'm glad this is all being recorded, because a lot of what I'm saying now really ought to be in the comments or somewhere, so that these decisions are as important as the code we are writing, right? Because contains what, I don't know where I was going. All right, so we're fine tuning this. Okay, now we also know that contains does not require an object, right? It just needs a vector and a string. So it does not need to be part of the team class as a member function. It can be a part of the team class as a static function, or so here's the decision, right? Both are valid decisions, and you have to make a choice right now. Okay, one of them, this is also possible, but it's really contrived and convoluted. You shouldn't make it a member because it's general, right? It doesn't require an object, right? It just takes a vector, and right? It's not saying in this team, right? Unless you said team : contains. Well, if you said team : contains, that's different, right? Then that contains could be part of a particular team, right? And then it is going to take only a string as a parameter. It's not going to take a vector as a parameter, right? I'll show you how to do that too, right? So in this case, how you would do that is don't, hey, Chanyi, don't cut it, but just, don't delete it, but cut it, okay? So starting at vector string, go all the way up to string, right? Go all the way up to the next, no, all the way, more. There, okay, cut, even the space after that, right? Even the space after that. Yeah, okay, cut it. Okay, now that is a signature of a method which says here is a string, and then you don't have to call it temp variable, right? So double click on temp var name, and then refactor, call it player name, right? Player name, call it player name. Yeah, so this is how refactoring. Hey, that looks familiar to me. So yeah, so maybe Xcode, maybe I have used a refactoring in C++ and Xcode, because this looks very familiar. All right, good.
Is that what we're trying to? What we're trying? Is
Yeah,
that
I'd make it singular without the S, but
Yeah, singular, not plural.
sorted? Oh, I see. We changed the sorted players. Yeah.
No, don't change that.
Yeah.
Okay. All right. Now, no. Here we're going to reverse all of this. Okay, we're going to change. We don't want to do it this way. I'm trying. This is a perfectly valid way of doing this. That's the reason, right? It's a valid way of doing that. I'm glad it's a YouTube video, so you know how there's 2 different ways of doing this. This is how you would do it one way. Okay, so you're going to create a function, a method called contains, which is just going to tell you true or false if the given player is contained in the team or not. Yes or no so far. It doesn't do it so far, right? But it will. We're going to change this function. Now, it's not going to change the team. Is it going to change the team? It's just going to tell you true or false. But is it going to change the team?
No.
No. Okay, good. So let's cover our backs, okay, and qualify this method with the word const before the curly brace.
Const.
Yeah, const before the curly brace.
Here.
Right? Yeah. Space, const space, right? All right, so that means that this is a method which is going to return true or false depending on whether the player exists in the team, and it's not going to touch the team itself. Nothing in the team changes. Yes or no? Okay. Now this function is not declared in the class, so you have to go to the header file and declare this function. Triple click on the line. No, triple click on the line first, and Command C. Triple click on the line, Command C. No, what happened? What happened to the, no, you have,
Yeah.
what line? Yeah, all right, get rid of
This
that.
one was it. This one
Yeah,
was
get
in.
rid of it. We'll put it back later. It's, you can type
Okay.
it later. Right, now triple click on this line and Command C, triple click, three clicks.
Yeah, I did.
You can Command click. Okay, now go to your header file. Okay, now under the public section, under the setters, before set musical names, because you have all the standard methods, right? Setters and getters and so on. After set size, hit enter.
Set player names is in the private.
Yeah, on line 25, on line 25. Yeah, so hit enter, and then paste what you have. All right, hit enter one more time, and then put a semicolon after the const. What time is it? Do we have time? Yeah, we have time. Yeah, more than, yeah, almost a half hour. Okay, good. Semicolon. Okay, now contains should be the first. Yeah, and get rid of the last one. All right, get rid of the last line, line 28. Right now. No, and then you don't need the team double colon because it's already inside the team class, right? So,
Mhm.
all right. Now that is a signature of a method called contains, which we have attached to every single object. Yes, this method is attached to every object. All you need to do is just give it a player name, and it'll tell you if the player is already in the team or not. Is everybody okay with this? Now we're going to completely destroy this and do it a different way. Yeah. Okay, good. All right, now let's do it a different way. Get rid of that. Triple click on the line and get rid of that. No, go back to the header file and get rid of that. Oh, I'll leave it there for now. All right. So, all right, go to the definition. All right. Okay, get rid of the line. Get rid of the line. No,
Can I comment that out? Because I'm not.
Comment it out. Comment it out. All right. Now go to your implementation file. All right. Now go to that function. Now we're saying, all right, you know what? This contains thing. It's just looking up a vector. And why should I attach it to an object? Right, and restrict it to just this object. Maybe there's other parts in my program which also need to do a vector check, right? Why should they only have to do it? So is that a reasonable thing to think about when you're designing a larger program, not just like a 100-line program like this, slightly larger program where you have teams, players, and all these things, and you also have other vectors, and you need to sort and you need to check it, right? So is it reasonable to expect that you may have those requirements? Yeah. Yes or no? Okay, good. All right. So if that is the case, what you will do is, well, you know what? This function here is basically just checking a vector if a string is contained in that vector. So it really shouldn't be part of the team class as a member. So let me go one step further, and move it from the team object into the team class. Well, mind you, this method could actually be global. It doesn't even have to be a part of a class at all. It doesn't have to be static, right? It can be global. But we're going to do one step at a time, just so all the steps are visible, right? Because unless David Copperfield like 10 steps and you don't see this magic, we'll do one step at a time. So you'll see how this is, this was a method inside of the object. All of a sudden it's gone, bam, like that. But it's working. How is it working? Oh, it's out there. I don't see it anymore, but it's out there, right? So that's what David Copperfield does all the time. Right? Yeah, in Vegas, you pay like $5,000 and go and watch it. But we're doing it one step at a time now. And so you can see what, and then you do that like a million times. Then, when you're teaching this method to someone else, all right, and you'll see that, oh, here's the method in the object. Oh, that method, all right, bam, it's gone. Hey, it still works. How is it working? Oh, it's out there. It's still working. Okay. So all of that magic has happened. A junior programmer will think that it's magic. Okay, all right, so here's what we're going to do. We're going to make this static, all right? So what we'll do now is, because it is going to be static, it does not have access to a private member, because members, like your player names is now part of a class, right? It's inside of the class. Now, if it's static, it doesn't. So what we need is, if it's static method, it needs two parameters now, not one parameter. It needs a string to search for the player name, right? But it also needs the vector to search in, because that vector is attached to an object. This is a static method. It could be called without an object. Yes. Okay. So this is cool, isn't it? Because 2 classes ago we talked about methods and static methods and what's the difference, right? So methods are attached to objects. Static methods are free floating but still inside the class. Yes. Now here we have a real opportunity to use these things and see the motivation for these, why these things exist, right? And the power it gives you, right, by taking away all the headache. That's really what it is. Okay, so what we're going to do, we're going to turn this into a static method. So the first parameter just needs to be a vector of all players. No, that's the second parameter. The first parameter should be string. No, it should be a vector of strings. A vector of strings. And then this is a static method, right? So It's not going to change that vector in any way. So let's mark that vector as const and also mark that a reference so that it could be a billion elements. It won't take take up space by copying the billion elements. It'll just pass a reference to the vector, right? But if it's going to pass a reference, this method shouldn't change that vector. So we're going to make it const also. So we'll just say const vector. Yeah, there you go. Fantastic. And you say ampersand and you say all players, all underscore players, all underscore players, and then comma. Right, and get rid of the parentheses and then space there. Okay, all right. Now, and now because it's static, it doesn't have an object to work on, right? So there is no.
You have an extra open parentheses. Yeah.
Yeah. Okay. Thank you, Mark. Okay. Now, because it's static, there's no object to work on, right? So the const doesn't really make any sense. Yes, the end const doesn't make sense because that end const means the object isn't going to change. So get rid of the end const, the const on the end of the line. Yeah, get rid of it. Now you'll notice this function, sorted players. Oh, and they double click on sorted players and change that to refactor that to all players, right? You can actually just copy paste faster, I guess, in this case. Okay. Yeah.
I think that clobbers.
Yeah,
like line 40,
hey,
for example.
Wow, that is
so maybe we shouldn't refactor everything.
But it's not a bug in Xcode. I can tell you. I suspect it's not a bug in Xcode. That only happened because Chanyu changed the first occurrence of all players by hand and then refactored the other ones. Right? You had player names on top in the parameter list. You changed that by hand. Yes, Chanyu?
Player name.
Anyway, don't worry. I think it's not an Xcode bug, okay? It is an artifact of how we decided to do the refactoring. You can check and confirm if I'm wrong. Okay, all right, now change. Let's do that. Change, just to double click on all players and Command C. Double click on all players, Command C. Okay, now double click on sorted players, double click and Command V. No, just Command V. Command V, paste.
Paste.
No. All right, good. Now you paste it. Okay, now same thing on the other one too.
This one.
Yeah, double Command V. Okay, good. All right. Now you don't need the break, right? You don't need the break, first of all, right? Yeah, we're going to fix this up. Don't worry. Okay, I'm talking to Xcode. All right. So get rid of the break because when you return, it's broken, right? Not broken. Return is an implicit break, right? Return.
Okay, yeah, that's something that I wasn't sure about. Thank you.
All right. Now that's good. Now also because it's Boolean, right? It's Boolean. Let's not take advantage of raw C, right? Because when you do 1 and 0, you're saying C++ gives me all these nice things like true and false, which are like syntactic sugar. C++ knows it's 1 and 0. You don't have to tell it it's 1 and 0, right? So, but by telling it 1 and 0, you're saying, well, you're giving me all these nice things like true and false. I don't want them, right? You take my raw stuff. So let's not do that, okay? True, turn true, that's good. Now you can get rid of the braces also, right? Get rid of the braces around the if, just around the if. In fact, not even around the for, but you can leave that around. All right, so, okay, all right. Now it says, why does it still say sorted players? You just say Command S one time, Chanji?
Yeah.
You hit Command S?
I think it's an issue in the header file.
Yeah, I did.
No, but you see the red thing? It says sorted players right here. Use of undeclared identifiers. It thinks that file is not sorted. No, in that file. If you go back to that file and hit Command B, I bet that'll go, right? It's just Command B and Command B. Hit Command B.
Command B.
Command B, yeah.
Oh yeah, it's gone away.
All right, no, it's gone, right? So that's fine. This is the error you should expect to see, yes? Because out of line definition is now different. What it says is that, well, you're defining contains in a different way from where the header file says the signature should be. So copy that line, triple click on line 23 and Command C it. Yeah, now go to your header file. Okay, now right under the current contains, paste it. Right, paste it there. Now we're just going to fix it up a little bit. Okay, put a semicolon at the end, enter, enter. Right, now because it's inside here, you don't need the team qualification. Get rid of the team qualification. Yeah, and it's going to be static. It's not attached to the object, so put a static word in front of the bool. Okay, all right, so now that is exactly the same thing we did before, except where we took the object away from the method and said, don't worry about the object. When you're called, I'll give you a separate vector. Yes or no? All right.
We need STDs before
Oh, yeah,
vector and string.
you need to STD double. No, not. Yeah, okay. Also for string. And the other one too. How come I didn't complain about the other string before? Anyway, we don't have time.
IOC.
Yeah. All right, so now go back to your implementation file. You saved that, right? Oh, no, wait a sec. Go back to that file. I thought I saw a problem. Go back to that problem, the header file. All finished. No, it looks good. Thank you. I'm sorry. Yeah, go back to your source file. And thank you so much for being so patient with me. Okay. All right. So that's good. All right. Set player names. All right. So now this function is being cleaned up. We can actually do one more thing. Okay. Now here's the decision. The reason for this decision is very, very subtle. Okay. The question is, should this method, which basically just takes a string and looks in a vector, should this be static? It should definitely not be an object method. Well, it can be an object method like contains, right? So if it's not an object method, should it be static, or should it just be a free floating global method? Okay, meaning that it does not even require knowledge of that it's a player name or things like that. So I'll show you how to do that. Right now we're saying it doesn't. Now if you have it this way, the way that we've done it so far, in your main, you cannot call contains except using team : contains. Yes, in your main, if you want to call that method that you've just defined, you've got to invoke it as team : contains and then give it 2 parameters. Yes or no? Currently, yes. The way that, yes, okay, right, which is which means that if I want to call this function, which is just doing a general purpose thing like checking a vector for a string, I still need to qualify it with the team. Why is this general function living inside of a team? Is that a reasonable question to ask?
Yeah, I mean, if we only going to use it.
But let's assume this project is big and there's in many places where you need to like check a vector for a string.
Well,
Then
the only thing I would say is I would give it a team declaration if we're using like a standard name, if contains is actually a standard library function.
Let's make it like a standard library function. Okay, so in fact, now what we'll do is even get rid of the static and make it totally global, which means anyone can use this function. Even people that use your library without instancing an object of your team class, they can still invoke your function, right? Right now they can, right? But they have to go through your team. All right, so in order to do that, let's go to your class. Header file, and get rid of this line also, right? So get rid of and comment this one also out, right? Comment out this one. All right, now go back to your other file. Here, set player names. Where is it? Contains, right? Contains. Now, copy that 22 to 29 all the way. Cut it from 22 to 29. Cut it. All right, and get rid of the blank line. 2 blank lines. Now go to your main. Okay, go to your main. So this can all live in team.cpp. It doesn't matter. But what we're doing is all of these little moves are invisible but highly significant, because this is how you gradually structure your program so that the right bits fall into the right places. Initially, when you do your program, it's the right bits are not going to be the right places, right? You have this function here, that function here, but eventually when everything is settled down, this should be here and this should be here. Yes. But what if a designer said, I'm not going to design my program at all until I finally figure out on a piece of paper where everything needs to live? They'll never get their job done. Right? So you have to have a reasonable level at where you say you're going to stop. Okay, say, oh, all right, okay, I have a reasonable idea of how to proceed. So the people who never get the job done are saying, I will not start until I know how to end. Then those are bad hires. So what you want to hire are people who don't care if the project will end. They just need to know if the project will run. Right? So you just need to see a few steps ahead to make yourself comfortable with saying, well, what I do now is not going to be wasted. Okay, so that getting that intuition takes a little bit of time. That's why I say, people always say, I want to learn programming in 3 weeks, 5 weeks, 10 weeks, 5 months. How can you learn all these things, right? Everything I tell you is really the result of years of experience. And you have to be in this, you have to immerse, and you have to be looking at other programmers. You have to interact with brilliant minds who are making these micro decisions that you don't notice in their code. And if you're just sitting in your cubicle and coding on your own, well, chances are maybe you will be a kick-ass programmer, but you don't get to see so many of these beautiful nuggets that people are flinging around all the time. So, so that's why this is important. So we've now moved this out because it's a global function and it's not a member function of a class. It's come completely out of the class, right? It was a static, so it came out of the class and became static. Then we decided it's not even worth being static. It should be global so that everybody can use it. And we're going to pull it out of the file itself, right? Now we make it a global function in main. So put it on top of main, right? Paste it on top of main. No, not there. On top, above main. Yeah. All right. Main. Yeah. Put it there. Paste it. Command V. Oh, what happened? Where's the body of your function? What happened to the body of that function?
Yeah, I think I deleted instead of.
Oh, just Command Z here a couple of times. Get it back. Yeah. Where is it? Set player names, is it? No. Where is it? Contains. Where is it? Contains. Command Z more until you get it. No, the body of the function. Yeah. Now cut it. Yeah. Command X. All right. Now you can go to that one. All right, great. Enter. Now we're going to reverse this, okay? Remember, this is not the right way, and I'm going to tell you, and maybe you can tell me why this is not the right way to do it. I will tell you why. This is each of these is a puzzle, right? Because now we said we're going all the way. It's like a pendulum. We started here, we went all the way there. We say no, it shouldn't be part of the object. We'll make it totally global. We're going here, but even that is not right. We're going to come back. Okay. And
is it because team.cpp does not include main?
I think you're saying the right thing. We'll come back to your question, your answer in just a couple of minutes after we complete this, Mark. Is that okay? Right? I think you're saying the right thing. I still haven't thought, yeah. All right, good. All right. So now here's the change we made. Because it's now global, there is no qualification for team : right? It's just a Boolean function. It's a global space Boolean function. So get rid of team : all right, now it's going to take two vectors, right? So there is no notion of players and player names here, right? So the first one can just be called vec, right? So double click on all players and now refactor, don't rename it, double click and refactor. All right, refactor, rename to vec. Rename to vec, VEC. Yeah, enter. Why is it not letting you refactor?
It's just loading.
Oh, it's checking all the files. Why should it check all the files? It's a function, it's a local parameter. All right, now change the player name variable to something else like key, right? Yeah, 3 letters like vec, right? Change. Key, K-E-Y, right? And above, you change the comment utility function to, change that to return true if key is contained in vec, false otherwise, right? So just one line and it should completely encapsulate what we're trying to do in that utility method. And we're not even saying it's a utility method because the name itself is very self-explanatory that it's a utility method because it contains. Yeah, all right. Now, because it says contains, sometimes what people do is contains, well, the first parameter is a vector. So that contains means there is a string contained in the vector, okay? So sometimes what people will do is make the name a little bit more self-explanatory without having to look at the parameter. So they'd say, instead of contains, you can call it bool vector contains, vector underscore contains, right? Oh, I finished that. Yeah. Key in vec, false otherwise, right? Let's make it explicit. Yeah. All right. Now on the next line, is it the next line? Yeah. No. On the next line already, where the name of the function is contains. You can change the name of the function to vector contains, right? Because now it's all very self-explanatory. Vector underscore contains. Vectors. It's just one word. You can because it's just one word. It's more effort to refactor it rather than just rename it right there.
Wait, I don't need
to
just
type vector VECTOR underscore. That's it. Enter. Okay. All right. Good. Now we have a general purpose global function. It's almost as though that function came with the vector class, right? All it does is going to do a linear search and return true or not, right? Everybody okay with this so far? Right. Now, someone ideally tell me why this is worse, right? Why is this a worse way to do this than what we're going to do now, which is it shouldn't be a free-floating global method like this. What we did before as a static private, right? Private static method of the class is the right thing to do. It should not be a free-floating method. Why?
Because team.cpp doesn't include main.
Yes, all right. So that is the right answer, Mark. Okay, thank you for that. I'd like someone else to rephrase what Mark said. Okay, to rephrase what Mark said in a slightly different way, if possible.
It's gonna make it complicated, and you have to go to main and back to a team H and pull up this and
Right. I think
and we only use it in the team CPP, and we're never gonna use it in.
But no, but what? Yeah. But what if vector contains is used in this is main? What if you have other CPP files in which you are doing vector contains, right? And you're using them. It's possible, isn't it?
Yeah.
Right. So if that is the case, I'm arguing that those other places where you're using vector contains should be calling the team static method, right? Maybe we'll make the team public static, not private static, right? But public static. So even if, yeah. No, in fact, we'll say the other places where you need to do vector contains, do your own, guys. Okay, you're not going to be using the team version because it's so simple. It's linear to do your own. Okay, so you just make it private static. So I'm saying private static is the best for this. I might be wrong, right? Something you have to find out, but I'm saying private static is the best, not global like this. Why? And the answer which Turkey and Mark are both alluding to is that Mark is saying, well, you know, you're using contains, but team.cpp does not include main.cpp. So where is the function? It's you only see the declaration, right? The client has the body. So that means you've created a class which has an external dependency. And this is the point that will come back to you repeatedly throughout your CS2A, 2B, 2C, that when you create classes, the classes need to be self-contained. Yeah. So if you have a class that will refuse to build until some external dependency, like battery is not included, right? So battery is not included, okay. But if someone says, you know, 35.7 ohm resistor not included, okay, then you're screwed, right? Like that. I don't know who we're going with that. So because this class that you build has an external dependency for something that needs to be part of the class, it's not a good class. So what we want to do is make our class as self-contained as possible. So right thing to do is go back to your class, right? We're going to patch up main later. We're going to come back to this on Tuesday, right? Or you can work on this over the weekend and, you know, post updates. And then we can do on Tuesday, we can take whatever we've got from today until then, including all the changes you've made over the weekend. What have you got? We can take that and continue building over, right? On that, you can play, right? But anyway, go back to the CPP file and do a command Z until you get back that method, until you get back the method all the way until the method you can keep hitting command Z until you get, is it this one? No, the one before this, you didn't have the first parameter. No, I think this is fine. This is good. Okay, team contains. Yeah, okay. Now here, what we'll do is instead of this, we can refactor. Okay, so we will say a team vector underscore contains, right? Team vector underscore contains, and because we want to make this, even though it's inside of a class, right? We want to make sure that it is a public utility method, but we're going to call it just so that our own team is complete. In addition to our own team being complete, we have a utility method we use that you guys can also use. Does that make sense? So if you look at, you know, big projects like Unreal, that's how they build a lot of things for Fortnite and Epic, but they say this is really cool and general purpose. It's part of this class, but you can still use it from outside the class. Yeah. So that is how I think we go around. All right. So now, all right, now go back to your, oh, by the way, change, on line 35, change contains to vector underscore contains. Okay, now one thing, no while loop there. I'm sorry, let's actually fix it up because there's some serious errors here. Okay, so I think it's, if you can you guys stick around for just a couple more minutes? It'll only take a couple more minutes. We'll just fix it up, right? So there shouldn't be another loop here. What we'll do is that if what you've done there is technically correct. Okay, what you're doing is that if the string exists in the vector already, generate another name. That's what you're doing. Yes. Okay. Now technically that's right, and you can take a programmer who's a reasonable mathematician, right, and say, is that okay? And they'll say yes, because it converges in the limit. Because if you think about it, the probability that it will not that loop, right? The probability that the loop will not terminate is exponentially shrinking. Yes or no? Because the first time around, what's the probability that not there, right? Second time around. So, if that probability is p, the second time around is p squared, p cubed, and so on and so forth, right? So it's exponentially shrinking. So you could say that, any reasonable programmer would say, well, in the limit, that method is going to return because it's a converging thing. And so they'll say, but, a mathematically minded programmer, I found, is not happy with that. Okay, because they don't want things to converge in the limit. They just want it to be absolutely true.
Also, with a sufficiently large vector,
Even then,
that's not going to terminate.
No, if it's a sufficiently large vector, it's going to search through the whole thing, but it'll search through the multiple things, right? Even if it's like 1 billion elements long, right? You give it a name and say, well, you search through 1 billion elements and say, no, it's not there, or it's there, right? It's generate another one. You got to search through the billion one more time, right? So it's a linear search every time. It'll take a long time. But the probability the second name is also not there is very, very small, because the first probability, the probability the first one is not there is 1 in a billion already. No, the probability is there as well. Anyway, so we've got to get the math
Actually,
right.
if you just limit num syllables to 1, once you
No,
have
we'll do it. We'll do it more.
7,
Yeah, I know, but we'll do it. We'll do it this way. Okay, for now, you can change this later. We want to make sure that it absolutely will exit the loop, no matter what. And to do that, we're going to say, if vector contains that name, what we're going to do is just change the name to name underscore I, whatever the value of I is. Okay, so if it's Bob, the second Bob is going to be Bob underscore 1. Okay, so at least we know, right? The probability of that, but think about it. The probability of seeing Bob underscore 1 is exponentially diminishing at the same rate as the probability in which your program is going to converge anyway. So the error, the thing is the same, right? Except that instead of the program crashing, you're saying it's going to return an underscore 1, underscore 2, and so on. Everybody okay with that so far? Okay.
Yeah.
So if and then you say if vector contains, temp. Actually, open a brace after open a brace after 35. At the end of 35, open a brace. Yeah, a space brace. Yeah. So no, not parentheses. Space brace. I think you need two parentheses, two closing parentheses, two closing parentheses. Change the get rid of the brace. Yeah, one more parentheses there. Okay, space and then brace. All right, brace. Okay, now the next line is fine. You want to say temp var name equals, and in fact, let's not call it temp var name. We'll actually call it temp. We'll just call it candidate. Just call it candidate. So right click and then refactor to call it candidate. Right? Refactor. It doesn't. Just right click and change the name. Oh, you haven't declared it. Oh, you do have it right up there. Oh, the very first call, right? The very first call. Not there, on line 34. Double click on temp var name and change that to call candidate.
I cannot rename.
Save your file. Save your file. Maybe it needs it to build or something before. Yeah. No. Or just double click and rename it. All right. Change that to double click and change that to candidate. 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 All right, we're just trying to making some cosmetic tweaks to make the code easier to read. Yeah. Now you don't have candidate equals. You've already got candidate right there, right? If the candidate is in the team, yeah. If the candidate is in the team on the next line, you don't need braces there. You don't need braces there, right? Get rid of the next line. Get rid of the next line.
Professor, I have to go, but thank you so much for the
Oh,
class.
thank you, Elizabeth. You can refer to the video, right? Which is 2 more minutes.
Yes.
We'll complete it. I thought most of you had gone already, right? So,
I'll watch them.
Thank you for attending, and thank you for your patience. Okay. All right. Thank you. So hey, Chanyi, get rid of the brace. Get rid of the brace at the end of line 35. On the next line, you're just going to say candidate equals candidate plus candidate plus underscore within quotes, underscore plus within quotes, has to be within quotes, within double quotes. Yeah, underscore. And then you want the number I turned into a string. So you say plus at the end, plus, you say two underscore string. This is a library method, okay, in the standard library. Open parentheses, I, open parentheses, I, close parenthesis, yeah, and then semicolon right there. Okay, enter. And then close the, yeah, that's it. Now, in fact, because, you have a space and then an underscore there, just make it a space. You don't need an underscore, right? Just make it a space. So it's a Bob space 1, Bob space 2. All right, so that's all. Now, if you have a duplicate, you're not going to try and generate another name because because if make a name is not guaranteed to, if what is it? Yeah, if make a name is not guaranteed to give you a brand new name, because how do you know? Make a name could be giving the same name over and over again. So you can't trust make name to give you a different name each time. Yes?
Yeah, if you limit the number of syllables to 1 after 7 names, you're out of options.
I'm sorry?
Just for example, if you change num syllables from 4 to 1, once you have, I think it's 7 names.
Oh yeah, totally. Thank you, Mark. Yeah, in fact, that is how programmers really run through these things in their mind anyway. Like, right. So what Mark is saying is that it's easy to instead of the professor talking for hours on end about this, you can just imagine that if your number of syllables is just 1, the maximum number of unique names you can get is 7. Right. So you can never ever get an 8th name which is different from what you have. So you'll be stuck in an infinite loop. Does that make sense? So the structure we had before with the while loop was dangerous because that would mean the program locks up, never returns. And this way, he'll say, do 1 after that. So thank you. All right. So does this make sense? So we made these changes. What is team set size, sorted players dot resize? Why is that sorted players? Why is sorted players underlined? Why is an error? Oh, out of line definition vector contains. Oh, we need to change up. Go to your .h file. We just fix up the the declaration of vector contains. Right, go ahead. .h file. Where is your sorted players? Is there a?
I think once we changed it at one time, it changed everything.
Oh, we changed that from sorted players to all players.
Yes.
Yeah, call it sorted players. Sorry. Underscore sorted players. I think it's better because the other places, all the errors should now go away, right? If you save it now, but we still need to fix up the declaration for contains, right? So go back to your header file. We'll fix up the where's contains. So the second one, the static bool, is the one we're using. The first one can go. The first line can go. And the first line can. We don't need that anymore. All right, now this is the one we're using, right? This is a static bool contains function, and it's not contains anymore. It is vector underscore contains. Yes, it's a standard double colon vector colon. No, it's vector underscore contains. It's our function called vector underscore contains. Okay, so this is a function that we have defined. It is static, right? And in the body of the function, go back to your CPP file. You'll see that it's all fine. Hopefully. All right. Why is sorted players not? You have to save it. Maybe save it and build it again. Command B. There you go. All the error is gone. Yeah. Okay. So does this make sense so far? What we've done is we just took what we wrote last class. We just made some very small tweaks to it. 99% of what we did today was basically just cosmetic tweaks and shuffling things around. Right. I don't know if we actually accomplished a great deal. You guys have to tell me, right? I'm going to shrink the code window for a sec here so I can see your faces again. But you have to tell me if this was useful in covering new ground, right? Because every time we want to cover a little bit new ground or more new ground. So was today's class useful in introducing some concepts that are important in eventual life as a C++ programmer or any programmer in general, right? Because there are lots of things that we touched upon which are probably not explicitly spelled out in the syllabus. But which I think will be useful both in terms of passing this class, because a lot of these things are in the exam, right? And also go towards designing good quality programs, right? You don't want to be turning out half-ass programs, right? Even though nobody's going to look inside your code, you're just going to compile it and release binaries, right? But still, why would you release a half-ass binary? Yeah. So these things, these kinds of things, and again, you never learn these things from me, because I can, like I said before, I can talk to you about this for 2 hours, 3 hours, 10 hours, right? The only way you learn some of these, if you found any of these beside frills, right, that I add, this bit of tips and information stuff, if you found those things useful, right, if you think they are useful and interesting, you obviously want to find more of those. Yes, right. If you want to find more of those, the way to get it is not from another person, right? Because other people, you find another top, anyone, right? Some professor who's able to sit down and teach you, no matter how long they spend, they cannot, because there's so many of those. Each person can only give you a sample. This is what's available, right? This is how we made our decisions. These are some of the things that we considered. Look how beautiful it is, right? So I can show you everything. So the goal here is to basically instill the taste in you, right? So lots of people don't like blue cheese or stinky tofu, right? And they don't want to eat it at all, right? So you just have to lock them up in a room and say, you don't have to eat anything at all. I won't get anything until you finish this, right? And so over a period of time, you develop a taste for it. And say, I want some blue cheese. I want some blue cheese. Okay. So this way in CS2A, you're locked in, right? You can't drop the course now. So you're locked in, you're forced to try all these other things, which are not part of the syllabus, right? But in my class, so that when you leave, you say, wow, you know what? Those things are really cool. I wish I get more of those. And the only way you get more of those, because if you say, I want more of those, I'm going to enroll in that class, I want to learn from this person, I want to learn, you'll not get it, right? The only way to get more of those is to go looking for it yourself. Okay. And the way to get more of it yourself is to code. Just keep coding, because coding is this enormous forest, this jungle, this Questopia, right? So many things out there to explore, right? You just keep walking and walking and walking. Everywhere you'll see some beautiful things, right? So you can't hire a guide for everywhere. You can hire a guide saying, okay, this particular trail is interesting, right? So we've done this once before. But once you've done the trail, you know how to look out for poisonous insects and deadly crocodiles. All right, you know where not to go, right? That's the purpose of a guide, right? The purpose of a guide is to show you this is a beautiful country, right? But these are the places you don't go to, right? So you can still enjoy this country, but this is the way you stay safe. Don't do some crazy ass stuff, right? In this country, this is the way you can enjoy yourself, and that is what a teacher does to you. Does that make sense? So keep coding and coding. Eventually you'll get the taste, right? It doesn't matter if you don't have the taste for it right now. If you think there is a future in it, if you think that you've seen someone who has a great deal of pleasure, who's deriving pleasure from it, right? Then obviously you want to derive pleasure from it too. And the way to do it is just saying, what is it that they find so cool about this, right? What is it that so many people are raving about? I want to find out. So keep coding, keep looking. Searching is the best way to find the answer. Yeah. All right, thank you so much for your time. I hope I didn't waste a lot of it, but we did manage to cover a significant amount of coding today, you think? Yeah? Okay, great. Please bring this code. Bring this code next Tuesday. No, don't work on this code. Work on this code like Turkey and you guys do, right? So work on this code, change things. It doesn't matter. Even if you screwed up totally, we can come back to this, right? We have a snapshot. So we're going to take this code, make some more changes next week. We'll see how it goes, right? We'll just basically take the code, run some ideas and pick one and do this, right? So we'll do that on Tuesday. By the way, this is week 10. This is week 10. No, it's week 9, is it?
I think it's 9.
Week 9. Okay. So we have 2 more weeks of classes. Most classes don't even have a whole week 11, right? They even use the second lecture of week 11 as review. I don't know how we'll do it. I'm happy to do lectures all 12 weeks, right? Even the 12th week, no new material is supposed to be covered per syllabus, per foothill guidelines, but we can have a class, right? Review old stuff and so on. I'm happy to do that. Next 2 weeks, I think it would be really, really cool if you just play around. When do we start talking about timing? Yeah, 2 weeks. You have 2 more next week of classes. Yeah, do more. Change the code, play around with it. And say, hey, I did this in order to try some idea. That's fine, right? Share that in Reddit, right? And say, I want to do this, it's not working. Can someone help me? That's great too. So all these things. And it's really fun. Some of the code that you're sharing on Reddit, people can, random people out there in the world can basically click on, Tricky's Replete link and then play that game. Yeah, they can play it on Replete, right? They click on it and play it. Random people can do that. Fantastic, awesome. You should basically just feel free to share it. Share the links you're creating on Replete and all these places, not just on our Reddit, right? You should just share these links on Stack Overflow, where you find someone asking a question and say, hey, yeah, we took that, solved the problem using this technique, and here's a game we built using that. Yeah, it doesn't matter. Share it, right? Share these things, and people will click on it. You'll get statistics too, and see, this is useful, this is not useful, comments. That way you can set yourself to have professors and teachers through your entire life, right? Because, you know, I'm here only for 12 weeks, but once you identify lots and lots of people on the net from whom you can learn, you can basically just bookmark them in your mind and say, well, you know, these are the places I need to go to when I need to know something. So you get education for free. Well, yeah, for college, util is so cheap, right? It's like 150 bucks, 170 bucks for, you know, local students anyway, for a class. It's so cheap. You know, the same class, it's a C++ class, if you were to do it at a UC, right? My daughter wanted to do this at Santa Barbara. It cost a lot more. UCs, even past quarters, like students, yeah, like 2,000 bucks for a class. Of course, I mean, I think the way that it works in UCs is that you can sign up for, I think, five courses per quarter, right? I think at $2,000 each, or some expensive amount each. And then after 5 courses, every other course is free. It's like, you know, you get a value pack, right? You get 5 courses, any number of courses after that free, right? So so if you're a really committed student who wants to save a lot of money, you can do 55 courses in 1 quarter, right? Only pay for 5. So you can do 50 courses for free. Well, of course, nobody can actually do that. But I think that's the way it works. You can get these extra courses for free. But still, you know, the fact that you have to pay a huge amount of money for something that is really worth free, right? Because you can get everything I'm teaching you is free. Everything I'm teaching you, you just go to Google, the answer out there. And it's not even, you know, you don't have to pay for getting the right answer, right? Because you can, so many times you can go to Stack Overflow or some of these reliable sites, right? You go to Quora, where you find a really reliable person who's given trustworthy answers in the past, right? And you look at what they're saying about some complex algorithm, right? And that person may explain it in a really nice way. You can bookmark it, and so it's all free. It's all free. YouTube, Khan Academy, everything is free, right? So these days, it doesn't even make sense to charge people for education, right? You should just be able to get what you want for free. Thank you so much for you know, being patient, humoring me until the very end, even after the end of class. Thank you so much. I will see you guys on Tuesday. Okay. Thanks.
See you. Thank you.